Hello, we are going to talk about the math in my sock drawer today, and it's really about the art of classification. So we're going to look at systems of classifying things, but we're going to use my sock drawer as an example. So here it is, my sock drawer. It is a mess. We're going to come up with some different systems that might help me organize all my socks in my sock drawer. Now, let's just talk about what it means to classify. And a definition is to arrange in categories according to shared characteristics. So we're thinking about groupings, right? Different groupings, and we usually put things together that have shared characteristics or things in common. Now, classifying things can go from simple to complex, and we're asked to classify things early on in our lives and our little child brains, and we don't really talk about the fact that we're doing that very often at all. We start out with a simple example of shapes and classifying shapes. Adults around us are always asking us when we're 3 and 4 years old, like, what is this shape and what is that shape? And we learn about triangles, squares, circles, and rectangles, for instance. But as we get older, our ideas or categories for shapes get more complicated, and we have more complex shapes like stars, and we have ovals versus circles. And then even later on, we might start to learn about different types of triangles, say. So here we have this diagram that's organizing our different shapes that we know. And it takes like the different types of triangles that you might learn about. You might have heard about an equilateral triangle or an isosceles triangle, or some of my algebra students are learning right now about right triangles. And those all group together into that category of triangle, but then they are separate and different on their own too. And four-sided shapes, which we call quadrilaterals, can also be grouped together, but have distinguishing factors for characteristics for different types of four-sided shapes. And then we can see a couple other examples of categorizing shapes, like the different types of triangles, some more detail about classifying the different types of triangles. And then we have here the different types of quadrilaterals or four-sided shapes. And something to notice about these three diagrams is that they not only break out the different individual elements or different types of triangles, for instance, different types of four-sided shapes, but they also show relationships between the different shapes, right? So this one shows how just all those different triangles are grouped together as triangle. This one breaks it down, and it says that there's different triangles that are kind of categorized by their sides, by the side lengths. And then there's different triangles that are categorized by the angles. And here, these lines kind of show how the different types are related to each other. So systems of classification get more and more complex, but they also show how things are different and how things are related to each other. We'll talk about more of that as we go along. There's three different classification systems that we'll talk about today. There are lots possible, but three that we come across often are Venn diagrams, tree diagrams, and a table or a matrix can be used to classify things. Let's look at those Venn diagrams first, and I bet you've seen a Venn diagram, and you might already know what they are and how they work, but here's a simple example. We're classifying animals. So we have two categories, land animals and water animals. So the circle on the left shows land animals, and the circle on the right shows water animals, or animals that live in the water. But in between, we have this area that overlaps and kind of creates a third category of animals that spend time both on the land and in the water. So Venn diagrams can be kind of simple like that, but they can also start to get more complex. And this one just still has two circles with one overlapping area. But the complexity comes in that we're not categorizing things anymore. We're categorizing ideas. So this Venn diagram has a circle that shows the characteristics of mammals and a circle that shows the characteristics of fish. And then that overlapping area shows the characteristics that fish and mammals have in common. So we're not classifying things or objects, we're classifying ideas here, and that starts to kind of get us towards where we can really be complex and sophisticated in our classification systems. Here's another way Venn diagrams can get more complex in that you can have more than just 2 circles. You can have 3 circles. In fact, you can have a dozen circles. But here's one with 3 circles, and you see how many more categories or groupings now we have. So we have that circle for whales, characteristics of whales, a circle for characteristics of fish, and a third circle for characteristics of shrimp. But now there's 4 different areas of overlap. This area here just shows where fish and whales overlap. This area shows the characteristics that are shared by shrimp and fish. And then there's this middle area here where it shows the characteristics that all 3 share. All 3 of those circles overlap in that middle area, and it shows that all whales, fish, and shrimp both live in water and can swim. So there's a level of complexity there. Here's a really complex example of a Venn diagram, but it's also kind of fun because someone took the time to categorize or classify candy bars, different types of candy. So you could pause the video here and take a closer look at that diagram and see how fun it is to think about all the different characteristics of candy and how different candy bars share characteristics or are different from each other. This Venn diagram is a little bit more serious than our candy Venn diagram, and it's one that all of my 7th grade math students have seen, where we're classifying numbers. So not only is the idea of classification and creating systems of classification kind of a higher order level of thinking and very much using your math brain, we sometimes do classification specifically in math. So classifying numbers. We learned about rational numbers versus irrational numbers, and we see that those 2 boxes do not overlap. There are no numbers that are both rational and irrational. There's no overlap. And then you can see that like the natural numbers sit inside completely the whole numbers. So all those natural numbers are also whole numbers, but you have whole numbers that are not natural numbers. This system of classifying numbers gets complex as we learn about different types of numbers like imaginary numbers and real numbers. And we can also show this classification of numbers in a different way. So this is again a Venn diagram for the classification of numbers. But here's a different type of diagram that has the same information. You can see that real numbers versus imaginary numbers and how those are separate. And then the irrational versus the rational numbers are separate. And then within those rational numbers, you have all these different categories within rational numbers. So this type of diagram we actually call a tree diagram. And another place that tree diagrams come up is in biology, when we're studying and classifying organisms. So here's what we call a tree of life, and it's a way of classifying the different organisms in our world. And you can imagine this gets really complex because there are millions of species on our planet. And to understand them, we kind of create this tree diagram where you can see bacteria go in one direction, and then you can follow all life forms to the branch that eventually leads to humans. And at the ends of these branches, they are really specific, like we get down to the species level, individual species. But as you go up the branches, you can see how the different species are connected or relate to each other. So here's a kangaroo, and we go up from kangaroo and human, and we can see that they're both in that category of mammal, which you can't read there, but we both know that, we all know that humans and kangaroos are both mammals. So it shows how they're different and how they're related or have similarities. Here's another more complex tree of life diagram with a couple hundred animals. And this one I just thought was really interesting and different and kind of beautiful in the way that the information is presented there. The third type of classification system we're going to talk about is a table or a matrix. And you all spent some time studying a very famous table called the periodic table of elements. So here we're classifying all the different elements, and there is only one element in each specific category, each little box, but this table tells us a lot of information The reason we call it a matrix is because we have different characteristics and categories that kind of cross each other, right? So there's this color coding going on in this particular periodic table, but we also learn, especially as we go further and further in our study of chemistry in high school and into college, that the columns of elements, all of the elements in a particular column have some shared characteristics. And then all of the elements in a particular row also have some shared characteristics. So the fact that any one spot on this table tells us, we can know what column it's in, and that will tell us some things. We know what row it's in, and that will tell us some things. We know what elements it's near, and that tells us some things. So there's a lot of information here in this periodic table of elements. Another matrix example or table example is our table that we created in algebra on classifying polynomials. And there's two different characteristics we used to classify polynomials. The first characteristic is the number of terms in the polynomial, the number of terms. And 7th graders and algebra students alike learned about the word terms. And you can see that if a polynomial or an expression, it's not a word for an expression, has just one term, we call it a monomial, like 3x or just 10 or negative 2x squared, that's one term. If it has two terms, we call it a binomial. Here's an example, negative 2x plus 18. And then the second characteristic is the degree of the polynomial, and the degree has to do with the exponent. So there's categories of the number of terms, there's categories within that characteristic of the degree, and that creates this actually really complex system of categorizing where you can see we have quite a few different boxes here. But any one box tells us two different things about the elements in there. It tells us the number of terms and the degree. So back to my socks. Let's figure out how we're going to organize and classify my socks. So I want to take a few moments here to think about the different characteristics and then categories that you might put my socks into in order to help organize them. What do you notice about my socks that would help you put them into different groups? All right, I'll show you what I came up with. Here I have different characteristics like length or the material they're made out of, and within each of those characteristics I have categories. Like I would break up my socks into their category of ankle length, mid-length, or knee-high length, and then the characteristic of material would go into different categories like cotton, wool, or synthetic. The purpose is, I mean that like I wear different socks for different things, like certain socks I'll wear exercising and certain socks I'll only wear lounging around my apartment. We could also talk about the characteristic of the print of the socks. So the solids, or are they striped or have dots on them? The type of weather I might wear each pair of socks in. So certain socks I wear for cold weather, certain socks I wear for warm weather. Maybe the type of shoes I'd wear them with, or how thick or thin the socks are as well. So let's use some of these characteristics and the different categories within those characteristics to organize my socks. We're going to start with a Venn diagram, and I started with this characteristic of the weather, the type of weather I'll wear each socks in. And this is definitely something I think about in the morning when I'm putting on my socks. Is it cold outside? Is it warm outside? And so I put all my cold weather socks in one group and all my warm weather socks in another group, and I realized that there are some socks that are kind of in between. So a Venn diagram is really a good way to organize this particular characterization group of categories, because we have those warm weather socks, cold weather socks, and those ones that are in between. And I could also do a tree diagram, because I thought, well, you know, maybe I'll organize my socks based on the print or what they look like. So I first could separate them into solid color socks or socks with prints on them. And then I could further break down those categories, the print category, into graphic prints versus organic prints, in other words, like plants and animals. And I can get another step further even and break up the solid colors into the different actual groups of colors like whites or blues, the graphic printed socks into stripes or polka dots, and then the organic prints into plants and animals. I could go even further, like this animal category. I could break up into birds, insects, monkeys. I got a couple different socks with monkeys on them. And so you could see how detailed you could go with a tree diagram and go all the way to where each sock is in its own little separate category. The third type is a table or a matrix. So here again, I went back to thinking about what types of socks I wear in different types of weather. So I have those kind of same three categories that I noticed from my Venn diagram, kind of warm or hot weather socks, the in-between weather mild socks, and then the cold weather socks that I might wear. But I added that characteristic of a material that they're made out of, because that might help me further organize. So before, when I did my Venn diagram, I had three categories: warm weather socks or hot weather socks, the in-between weather, mild weather socks, and then the cold weather socks. But as soon as I just add one more characteristic with three categories, cotton, synthetic, and wool, then all of a sudden I have now 9 different boxes to put my socks in. So I started with 3 in that Venn diagram. Doing another characteristic makes it much more complex. Now I have 9 different boxes. And it also reveals some things about my socks, right? And it shows for sure that like all of my cotton socks get worn in that warm weather or mild weather. And all of my wool socks get worn in that mild or cold weather. You can even look, if you look across in the rows, you see, oh, when the weather is cold, Miss Van Kirk is only wearing wool socks for sure. When the weather is mild or in between, you never know. You never know what you're going to get. You might get some cotton socks, some synthetic socks, or some wool socks. And when the weather is warm, it's definitely a good chance that I am wearing cotton socks and maybe some synthetic socks, depending on what I'm doing. So there you go. There is a table or a matrix organizing my socks. We saw a tree diagram, and we saw a Venn diagram to organize my socks. There are lots of different things that you can classify, like I said, objects or ideas. You can be really creative. Like this one is a Venn diagram of superheroes. You can pause it and take a closer look and look at the different ovals we have about superheroes that fight crime, superheroes that are wealthy or rich, superheroes that wear red. And you can see where different ones fall in those different categories. Here's a really complex looking Venn diagram where someone classified all of the characters from Smash Bros. You can again pause and take a closer look at that and see how interesting it is, where the overlaps are, where things are separate from each other. This one I thought was really interesting because it's not classifying things, it's actually classifying like activities, kind of. This is, I imagine, made by somebody who was planning a family Thanksgiving, and they were thinking about what they need to do to get ready for that family Thanksgiving. And so they thought, oh, well, there's 2 different categories of activities: of planning meals versus shopping. And then you can further break down that planning meals task into doing a Pinterest search or just a general web search or looking up old recipes that you already have. You can break up that going shopping category into food shopping and versus shopping for other things like table settings or chairs. So this is classifying like activities, basically. You're planning out how you would get ready for something. You can use a tree diagram. Here's a really fun diagram that's really kind of a matrix. It doesn't quite look like a matrix, but it is a system of classification where somebody was organizing information about the different spells in Harry Potter, and specifically the spells that were said out loud in the books, not ones that were nonverbal or implied, but ones that were specifically said out loud. So it reveals some interesting patterns when we do this type of classification. Here we have across the top, the different colors are the different books, starting with the first book, The Sorcerer's Stone, and it's kind of a blue color. And so you can see that blue dots are the spells that were said out loud in that first book. And it kind of makes sense if you think about it. There's not very many blue dots from that first book, so not very many spells spoken out loud in that first book. But as you get further along in the series, there's lots. Like there's so many purple dots for the spells that were said out loud in the last book. So this kind of tells you something about it, and it kind of makes sense. If they're brand new students, they don't know very many spells, they're not going to say very many spells. But as they become more and more skilled wizards, there are definitely more spells being said out loud. So you can come up with all different types of things to classify. Here's a little brainstorm that some students came up with of different things or ideas that you could classify. And you can do this by just, writing down different, like all of the TV shows you watch. You can write them down on sticky notes or just pieces of paper or a little 3x5 cards. And then you can use those as a way to move them around and sort them in ways that will help you come up with a system of classification for those things. I'll have further instructions about how to do that in the assignment and what the expectations are for your classification system. But I really look forward to seeing them. I look forward to seeing the creative ways that you classify things and the different types of things you might classify. And then I will share with you, after you share your classification systems with me, I'll share with you what I decided to do exactly with my stuff.